All right, let's look at the next question. That is question number 11. The problem says that in triangle ABC, AB equals to 6, AC equals to BC equals to 7 centimeter, CP is the median, and which of the following is the area of the triangle? All right, so you are required to find the area of the triangle given the required information. Okay, let's look at the solution. Let's visualize this first. Let's plot what is given to us. So this is what is given, 7 7, and this is AB is 6 centimeter. Now look, CP is given as the median, and it is also given AB equal to 6 and AC and BC, they are equal to 7 centimeters each. That means it is an isosceles triangle, right? And in an isosceles triangle, the median is the perpendicular bisector of the opposite side, right? So here what we get is that AP will be equal to PB, that means equal to 6 by 2, that is 3 centimeter, and these angles, angle CPB equals to angle CPA, both equal to 90 degrees, right? So we can now use Pythagorean theorem in triangle CPB. We want to know the area of the triangle. So we have the base, and if we know the length of the CP, then obviously we can get the half base into height will be the area of the triangle, right? So how to get CP? Just use this Pythagorean theorem. In this, CP will be equal to root of hypotenuse square minus square of the other side length, that is 3 square. So 7 square is 49, 49 minus 3 square is 9, 49 minus 9 is 40. So root of 40, that means root of 4 by 10. 4 is inside the radical sign, so when it comes out, it will become 2. What you will be left with? 2 and then square root side 10 or 2 radical 10, right? So area will be half base into height, that means half into 6 into 2 root 10. 2 get cut, what you are left with is 6 root 10 centimeters square. Area is always, the unit is square, right? So 6 root of 10 square is option choice E. That's our final answer for the 11th question. Let's look at question number 12. Another interesting question that relates to symmetry. As you can visually see, it looks like there is a lot of symmetry involved. So let's read the question. We will come to the solution later. ABC and PQR are two identical equilateral triangles, all right, overlapping each other. Okay, so ABC and PQR, these are two identical equilateral triangles. They are exactly the same and they are equilateral, meaning all sides of those triangles are equal. All right, this is given and they overlap each other in the given manner. The area of the overlapping region, quadrilateral PXBY, this quadrilateral, this diamond shape or kite shape that you see, is equal to twice the area of the triangle AXP, that means this triangle. Okay, let's see whether that will be always or sometimes of it. Now at the very outset, this, as I said, looks to me a very symmetrical figure. So it looks like if you just join x to y, then you will end up with all equilateral triangle, isn't it? Let me make it for you. What I mean is that if you just join this, it seems that look, this and this, these will make 6 congruent triangles. And if that be so, then the area of this quadrilateral should be actually, because it is made up of 2 triangles which are congruent and again congruent to triangle AXP, and therefore this, if this is, let's say, A, then this should be, the area of the quadrilateral should be 2A. That means it should be equal to twice the area of the triangle, and it should always be true. Let's get to the next question. Question number 13 through 16 refer to the following information. Directions. There are 4 questions based on the table that follows, one of which is asked alongside. Okay, the table shows the data regarding the percentage change in the number of units manufactured by a plant during different months in year 2. So Jan to July is part of year 2. All right, so they have given percentage change over last month. Okay, these are the percentages and certain areas are blank, and percent point change in percentage change over last month. All right, again some data with some missing data, right? Okay, round up the decimal values obtained, if any, during calculations to the nearest integer value. All right, so these are the directions. So the first question is net percentage change in the number of units manufactured from December of year 1 to March of year 2. Okay, and that is quantity A, and quantity B is 35%. All right, and then we have to compare quantity A with B. Okay, so that's a type of question that we have here. Look, before we can solve this, it is important to understand the meaning of percentage change and percent point change in percentage. All right, let's do a little bit of theory then. So, percentage point change, what is that? It is the simple arithmetic difference between two percentages. For example, percentage point change is the final percentage minus initial percentage. If it is, let's say, final is 5 and initial is 2, then percent point change would be 5 minus 2, that is 3%, right? Whereas percentage change, it means the rate of change with respect to the original value expressed as a percentage. So we know that percentage change is the final value minus initial value divided by the initial value times 100. Okay. So for example, if a quantity increases from, let's say, 10 to 20, right? Then what is the change? From 10 to 20, that has become 20 minus 10 is 10, and 10 over 10 would be 100%, right? 10 over 10 will be 1 times 100 is 100%. So you know that percentage change would be 100%. That means that the quantity has doubled. So 10 has become 20. You know that, right? So these are the two things, please keep in mind. Now let us plot this. So you can see I have already done the plotting. I'll just explain that to you. See here, as I said, percentage change over last month, okay, and percent point change in percentage terms, right? So let's look at this. See here, they have already given minus 20. So 18 minus 20 is minus 2. You look at it this way, or you say that, look, if this value is x, so x minus 18% would be equal to minus 20. That's the percent point change. If that be so, then if to find x, you add 18 on both sides. Minus 18 will go to the right side, will become plus 18. So minus 20 plus 18 gives you minus 2. Either which way you get minus 2. Okay. Same way, they have given 8 over here and minus 5 over here. Either you add minus 5 and 8 to get 3%, or if you consider this value, May value, that is the percentage change over last month value for May for year 2 as y, then y minus of minus 5. Remember, it is not y minus 5. Okay, that will be wrong. So here it is minus 5. So you have to put that in bracket and then change the sign accordingly. So be careful. So y minus of minus 5 is equal to 8, right? This is the 8 that I'm talking of. So y is equal to, here it will become plus 5. So when it goes on the other side, it becomes minus 5, right? So y equals to 8 minus 5, that is 3%. Okay. Same way, z, 6 minus 8 is minus 2. Straight away you get that. Or you get, if this is z, you get z minus 6 equals to minus 8. And then add minus 6 on both sides. Sorry, not minus 6. Add plus 6 on both sides. So you will get, this will cancel out. Then you will get minus 8 plus 6. That is minus 2, right? That is how you get minus 2. Now this percent point change is very simple. It is, if you want to calculate for this, then it will be 18 minus 10, that is 8. For minus 20, they have already calculated that. Actually, it is minus 2 minus 18, that is minus 20. Minus 3 you will get, because minus 5 minus of minus 2 will become minus 5 plus 2, that is minus 5. Plus 2 will give you minus 3. So you get minus 3. That is how you will get. And here they have already plotted 8. So for this blank, it will be 6 minus 3, that is 3% point change. Please do not calculate until and unless you need the data. Otherwise, you will just waste your time. Okay? And time is precious, particularly on any competitive exam. Time-bound test, I mean. So let's now look at the problems, and we will not consider this data. Okay, this was just for demonstration purpose. We will calculate the required data as and when we need it in the problems that we see from 13 to question number 60. So let's look at the 13th problem. Net percentage change in the number of units manufactured from December of year 1 to March of year 2. That is quantity A. Quantity B is 35%, and we need to compare the two quantities. All right. So basically, we need to find quantity A. That is the net percentage change in the number of units manufactured from December of year 1 to March of year 2. Fair enough. All right. So here is the table. Year 1 December would be somewhere here, and this is all year 2. We need to find the net percentage change in the number of units manufactured from December to March. All right. So that is the period. So for example, December, that is for year 1 December, let's say it is 100. January would be 10% more than December, so it will be 100 plus 10, that is 110. Now February is 18% more than January, so what will be 18% of 110? 1% would be 1.1, 2% would be 2.2, isn't it? So 2% is 2.2 and 10% would be how much? 10% is 11. So if I take 20% minus 2%, that will make it 22 minus 2.2. I hope you are following me. So we get 110 plus 22 minus 2.2. That's an easy way to calculate rather than calculate exactly 18%. That means 18 by 100 times 110 and then cut the zeros and then 18, multiplication, 18, 11, all those things. Okay, this is an easier way of what I have showed you. So, and if you are good at percentages, this works, right? So 110 plus 22 minus 2.2 will give you how much? 22 minus 2 will give you 20. 20 plus 110 will approximately be 130, right? Okay. So now you got February as 130 approx data, and March would be how much? March is minus 2. So you have to subtract 2% from 130. 1% is how much? 1.3. 2% would be 2.6. So round 2.6 to the nearest integer, that will be 3. So 130 minus 3 would be 127. And mind you, they have already told you to round up the decimal values obtained, if any, during calculations to the nearest integer. Okay, so wherever you see that decimal value, please round it to the nearest integer. All right, so let me write it here. It will be this thing. I can say that it will be 3. Okay, all right, and this I will round it to 2. That is how it is. Okay, fair enough. So percentage change between March and December would be how much? March is 127 and December was how much? 100. So final value minus initial value divided by initial value times 100. That will be 127 minus 100 over 100 times 100. This 100 and this 100 will get this 100 and this 100 will cancel out. What you are left with is 127 minus 100, that is 27%. And 27% is quantity A. It is definitely less than 35%. So our answer is clearly option B. That means quantity B is greater. 35% is greater than 27%, right? So we have solved the question number 13. Now let's look at question number 14, again based on the same table. If the difference between the number of units manufactured in April of year 2 and July of year 2 was 1.7 million, what was the approximate number of units manufactured in April of year 2? Okay, let's look at it. Let's plot the required data. What do we need? If the difference between the number of units manufactured in April of year 2, so one is April, okay, and July of year 2, was 1.7 million. What was the approximate number of units manufactured in April of year 2? All right. So let's start with taking April data as 100. May is 3% more, so 100 plus 3 is 103. June is 6% more than May, so 6% meaning let's take let's say 1% of or rather, all right, let's take 10%. 10% would be how much? 10% would be 10, 5% would be 5 of 103, isn't it? And if 5% is 5, we have to add one more percent. That means we have to add one more to it. That means, I hope you are following me. Or shall I write? Let me write how I have calculated that. Look, the easy way to handle percentages is work on 10% and 1%. If you want to find 18%, let's say, then you find 20% and you reduce 2%. Okay, these are the simple tricks on percentages. Okay, so for 103, I have to add how much? I have to add 3%. Sorry, to not May. May I have already found. For June we need to find, and it is 6% more than May. So for May it is 103. For June we need to find. June is we have to add 6%. So to add 6%, easy way is add 5% and thereafter add 1%. Okay, so 5% would be what? It will be half of 10%, isn't it? Let's take 10%. 10% would be how much? 10% would be 10 by 100. That means 1 by 10. That means 103 divided by 10 would give you 10.3. Rounded off to 10. 10 by 2 will give you 5, and 1% would be what? 1 by 100. So 103 by 100 would be 1.03, isn't it? 1.003. You can round it off to 1, right? So add 1 to it, 5 plus 1, that means 6. So essentially what you get is 103 plus 6, that will give you 109 for July. That is how I got 109. Clear? Okay. Now, same logic, you reduce 2% from June figure to get July figure. 1% would be 1.09, isn't it? 1 by 100, 1.09. 2% would be twice of that. So you can say that 1.09 could be rounded off to 1.1. 1% is 1.1, so 2% would be, okay, let me do it here. 1% of 109 would be 1 divided by 100, that means 1.09. 2% would be twice of that, so what you get is 2.18, isn't it? Rounded off to 2. So what you do is reduce 2 from 109 to get 107. That is how you got. Clear? Alright, fair enough. So let me delete some of the annotations. Alright, I had already calculated that before for you. So this is how it was. Okay, 1% of 103, but I showed it to you, so you can just ignore that. So difference is, now look, we have to take this, since we have to find the difference, it is now we can extrapolate this figure to the variable x. So if it was, let's say, instead of 100, if it was x, okay, rather if instead of 100, if it were x, then you would have got, instead of 107, you would have got 1.07x. How? Divide both the sides by 100, okay? You will get exactly in terms of x. So it means 7% increase between x and 1.07x. There is a 7% increase, okay? So what is the difference? The difference is 7% of x, that means 0.07x. That difference of 0.07x is equal to 1.7 million. So what should be x? Divide both sides by 0.07. So what you get is 1.7 divided by 0.07. Take care of the decimals. What you get will be 170 by 7, and you will get 24.28. Rounded off to the nearest integer, you will get 25 million. Answer is option D. Clear? So I hope you are enjoying this video. If yes, please do give this video a like. Please subscribe to my channel, and please share this video with the other concerned people. Thank you. Let's move on. Let's do question number 15. Which of the following is the approximate simple average monthly percentage change in the number of units manufactured from February of year 2 to May of year 2? So now we have to calculate the simple average monthly percentage. Simple average monthly percentage. Okay, fair enough. So this is our data. What we need to find is manufactured from February to May of year 2. So we will plot the data from, 18 minus 20 is minus 2, and minus 5 plus 8 is 3. So we have these two data points filled in. Now year 2, we are dealing from February to May, so we are in this space. Okay, February, let's take it as 100. If this is 100, minus 2% would mean 100 minus 2 would be 98. Further, you need to reduce 5% from 98. How do you do that? 5% from 98. So 10% would be, divide by 10, that means 9.8, isn't it? Half of that would be how much? 9.8. Or you can just, so how do you reduce 5% from 98? See, actually 98 is very, very close to 100. So straight away you can just reduce 5 from 98. Okay, 98 minus 5 gives you 93 approximately. Otherwise you can just take 9.8 will be how much? 9.8 will be 10%. Half of that will be 5%. That means half of 9 will be 4.5. Half of 8 will be 0.4. So you get 4.9. Again, that is close to 5, right? See how close? So therefore we could have just taken 5 initially. Okay, so 98 minus 5 is 93, so we got this. Now add 3% to the April figure of 93. 3%, to add that, maybe you can do this, you can just take 1% and multiply by 3. 1% would be 0.93. 0.93 is close to 1, so 1 times 3 will be 3, so add 3 to 93 to get 96. I hope that is clear. Okay, so we got this data. Now look, they're asking us to find number of units. The what is the simple average monthly percentage change in the number of units manufactured from February to May? What is the change, average monthly percentage change? So we have to find what is the change from February to May. What is that change now? So we took here instead of percentages, here now we have the number of units, right? And we are required to find the average monthly percentage change. So average meaning it will be spread between all these concerned months. That means from February to May, right? In this period. What is the change? Starting is 100, final is 96. So what should be the change? Change is 100 minus 96. That means minus 4%, isn't it? In 3 months. Look, this is again very important. It is not in 4 months. Why? Because from February to March is 1 month, from March to April is another month, and from April to May is another month. So there are 3 periods, 1, 2, and 3. Clear? So in 3 months, the reduction is 4%. So simple average monthly change would be minus 4 divided by 3. That means minus 1.33%. Answer choice B, right? Let's look at the last question in this, for this data set, I mean. So let's read it. If the number of units manufactured in June of year 2 was 12 million, which of the following was the approximate average number of units manufactured per month from May of year 2 to July of year 2? All right, let's plot the data. If the number of units manufactured in June of year 2 was 12 million, so June figure is given as 12 million, all right. And what is that? We have to figure out which of the following was the approximate average number of units manufactured per month from May. We have to find the approximate average number of units manufactured per month from May of year 2 to July. All right, so we are talking of this data point. All right, fair enough. So we'll have to plot these two. Let's do that. So June is 12 million. May, we need this data. So we'll quickly do minus 5 plus 2, that will be, minus 5 plus 8, that will be 3%. And 6 minus 8 will be minus 2%, isn't it? So now we need to find the approximate average number of units manufactured per month. All right. So what is the difference? So let's say if May was X, then June would be 6% more. That means it will be 1.06x. How? X plus 6% of X. That means X plus 6 by 100 of X. That means X you take 1 plus 6 by 100, right? So you get X into 106 by 100. That means 1.06x. Clear? I'm sure you knew this, but just in case, or maybe those who have not understood, it was meant for that. But if you already know that, I'm happy. Okay, so 1.06x is equal to 12 million. Now we can substitute, right? So this will give us the value of X as 12 over 1.06, and I'm working on millions right now. So 12 over 1.06, remove the decimal, 2 zeros up, that means 1200 divided by 106. You get 120, so 106 ones are 106, you are left with 14, bring down the 0, then 140, how many times? 1 time, 106, you are left with 34, put the decimal, bring in 0, so 340, so it will go how many times? 3, at least 3 times, so 11.3. So May is 11.3 million. Do not reduce, just simply from 12 million, don't reduce 3%, okay? Why am I saying this? See, here the numbers are not that dispersed, but sometimes you will get erroneous data if you just do that. Because look, if you increase, let's say from 100, if you increase to 125, the percentage change is how much? 125 minus 100, that means 25 by 100, that means 25 by 100 would be how much? What will be the percentage change? It will be 25 by 100 times 100, right? That means 25% increase, isn't it? But when you reduce from 125 to 100, the percentage change will not be the same. What is the reduction? 25. But here the base has changed. Now you are reducing 25, that's fine. But it is on 125. So what's the change here? It will be 25 divided by 125 times 100. That means it will be 20%. 25 ones are, 25 fives are, 5 ones are, 5 twos are, and then 0. 20%. Got it? So this is 25%, but this is 20%. So don't do that. Don't just reduce the value just like that, okay? It is not exactly the same. Here, and another part is that here May 3%, it is this 3% does not mean that there is a linear relationship between this 3% and this 6%. No, it means this 3% is not based on June. This 3% is rather based on the April figure. So it says that it is 3% more than the April figure. So so you cannot, it has a bearing on the April figure. It is an increase over April. It does not depend on June figure. June figure is 6% more than May, so the June figure depends on the May figure. It is that way. Okay, so don't make that mistake. Even though, I mean, for data which is closely related and not very dispersed, sometimes you may get the same answer, but that does not mean that the process is right. Okay, sometimes you will do a disservice to yourself if you don't follow the proper process. Okay, all right, so let me delete all this. We found the May data. Okay, we have the June figure. Now it is pretty simple. We just have to find the July to take the average. July would be 2% less than June. So what will be 2% would be 0.24, right? 1% would be 1.12 and 2% would be 0.24. Reduce that. What you get is 11.76. Now our job is absolutely simple. Just add 11.3 plus 12 plus 11.76 divided by 3. You get 35 divided by 3. You get 11.66, which is close to 11.7. But look, instead of doing this calculation, if you look at the data, then you can observe very clearly that, look, instead of putting 12 here, if you put 11.3, 11.76 and 12 that way, okay, you just move this around and divide by 3. So there are 3 values, and look, they are almost equally dispersed, right? 11.3 is what is the difference between 11.3 and 11.76? Almost 0.4. And what is the difference between 11.76 and 12? Almost 0.4, right? Almost, right? So ideally 11.76 should be the answer, and if you round it, 11.7. Okay, so 11.7 should ideally be our answer from here itself. We don't need to do this calculation, but if you do, you still get the same figure. So answer is clearly C, 11.7 million. Okay, all right, so we have completed this data set. So that brings us to the close of this session. I hope you enjoyed the video. If yes, please do give us a like and subscribe to my channel. Please hit that bell icon so that whenever I post content on math, English or soft skills, you are notified. Thank you so much for your time. I hope to see you very soon in my next video. Thank you. Happy learning.